So we need to describe all skew-symmetric scalar matrices. There are a few rules which skew-symmetric matrix needs to satisfy. First of all, skew-symmetric matrices. So first of all, it has to be a square matrix. So square matrix. If matrix is not a square matrix, it cannot be skew-symmetric. And the second condition is that the transpose of a matrix is equal to the negative of itself. So for instance, let it call some matrix A, such matrix A, then the transpose of matrix A equals negative A. And if these two conditions are satisfied, then matrix is said to be skew-symmetric. So also for skew-symmetric matrices, any entry A, J, I, so some entry A in J column, in J's row and I column equals to negative IJ. So it equals to negative entry A in I's row and J column for all values of I and J. And the diagonal elements of a skew-symmetric matrix are equal. So basically any A1 equals A2 equals equals A n. And they equal 0. They all equal 0. How we know that? Because the diagonal elements are characterized by the general formula Aij, where I equals j. And if I equals j, then Aij equals Aii equals Ajj. And if it's a skew-symmetric matrix, then Aji equals negative Aji equals, so that means that Aii equals negative Aii, and that means that Aii equals 0. So that's why all diagonal entries of a skew-symmetric matrix equal 0. So let's look at some examples of skew-symmetric matrices. For instance, matrix P, which is 2 by 2 matrix, equals 0, negative 5, 5, and 0. As you can see, the diagonal entries, so here equals 0, and A12 entry equals negative 5, while A21 entry equals 5. So we get that A12 equals negative A21. Another example of skew-symmetric matrix is, for instance, matrix Q, which is 3 by 3 matrix, and it consists of entries 0, 2, negative 7, negative 2, 0, 3, 7, negative 3, and 0. Again, as you can see, entries which are diagonal entries here equals 0, while for instance A12 equals 2, A21 equals negative 2, A13 equals negative 7, and A31 equals 7, A23 equals 3, and A32 equals negative 3. So that's why this is a skew-symmetric matrix.